some more examples of finite automata. Uh, let's see what comes up. So this is an automata. Guess what it does it? What is it accepting? So this is the starting state, and this is the accepting state. If you read, you start from here, and if you read letter A, you will end up at the accepting state, and if you read letter B, you end up at the acceptance state. And once you're here, you will not move anywhere. You will stay in this accepting state no matter whatever letter you read. So from here you can guess that this FA actually accepts anything but at least one letter. Conclude that this machine will accept any letter excluding null. So it will not accept null. So the starting state is not the accepting state. So if you read null, it will not accept, but if you read any other letter, it will accept it. So this machine can be translated into this regular expression, that a plus b with superscript plus sign. And next we have another machine. Here the starting state is also the accepting state. So even if you do not read any letter, or in other words, even null will be accepted with this machine, and any other letter will also be accepted. So definitely it will accept anything including null. So this is a regular expression for this machine. And next we see another example. Here you have a machine where you can see that if you read letter A and then another letter A, so you can say consecutive A's or double A, then you will end up in this accepting state, and once you are here, you will stay here for whatever letter you read. You will not move anywhere. So the only condition to reach this point is you must read the letter double A. Or the other path also exists, which says if you read letter B and then consecutive B, so it means double B, you will reach on the accepting state, and then you will stay here no matter whatever you read. However, if you read the letter A and then you read letter B, then you will come to this path. So it will accept that if you get another B, then you will get double B's. You will move here. In the same way, if you read letter B and then you read letter A, then we will expect that you get another A and you reach here. So the idea is you must read at least a double A or a double B, then you will reach the accepting state. So here we see another automata. This says that first we see the regular expression. It says first you can read a single letter, either A or B, then another single letter, either A or B, but the third letter must be B, and then you can have anything after that. So if you want to draw the automata for this, then we draw the starting state. From the starting state, you read any letter A or B, you move to this state. Like say I call it 1, I call it 2. From 2 you can move the third state after reading any letter A or B, and then from the third state the third letter must be B, then you will reach this accepting state. Otherwise you will move to this state 4. Let's call it 4. This is 5. And state 4 is a sink state. It means there's no way back. Once you are here, you are trapped. So this is a trap state, and your word will always be rejected. But once you are here, you are on the accepting state, and no matter whatever you read further, you will stay on the accepting state. So this automata makes sure that the third letter must always be B, and you can have any two letters in start and anything at the end. So let's see another example. Here you can say this regular automata accepts only one word, that is BAA. This is a regular expression for this. So you define the starting state, read letter B, move to this state A and A. So this is the accepting path, that you read the letters in the sequence B, A, A. And during this path, if you read any other letter that is not in this sequence, like if you read another B after the first B instead of A, you will be dropped to the sync state. So for all other exceptions, you will come to the sync state, and sync states means you are rejected and you do not have any way back. So this is a finite automata for this regular expression. Next we see some more examples. Here you have an automata. This automata accepts two words, either BAA or AB. So this is the starting state. You read B, then A, then A, you end up here on the accepting state. Similarly, from here you start, you read A and B, and you end up at this plus sign accepting state. And for all other letters which are not in this sequence or in this sequence, you move to this sync state, and this is dead state. You will not come back from here. So all your words will be, all other words will be rejected except these two words. So to further elaborate the concept, let's have a few more examples. Let's see what this automata does. The starting state is also the accepting state. So if you have null letter, you are accepted here. But if you read any letter like A, B, you will go to this state and there is no way back. So it means if you read any letter, you will end up here. That is not the accepting state, and that is actually a sync state. There is no way back. So it will only accept the null letter or empties. So only null is accepted in this automata. It will not accept any other thing. Next, see another machine. Here you can see that if you, here again, the starting state is also the accepting state. So you can say it accepts null, just like this. So if you have null, if you read null, you are still on the starting state and accepting state, it will be accepted. Or what else it will be, it will accept. If you read A, you stay here, but when you read B, you move here, and if you keep reading B's, you will stay here, and once you read A, you come back to the accepting state. So here you can conclude that the word should end at A. So whenever it ends at A, you are on the accepting state, and whenever you read a letter B, you move to this state and stay there until you read another letter A. So you come back here. So it will accept anything which ends at A. So anything can be written by this A plus B whole, and it should end at A. So this is a regular expression for this automata. And next we see this. Here you can see that when you read letter A, you move to the accepting state and then you stay here. But whenever you read letter B, you come back to the starting state, and for all next letters B, you stay here. So you move to the accepting state only whenever you read letter A, and you stay there as long as the letter is A. So but it doesn't accept null. So it is the same thing as this one. The only difference is that it doesn't accept null. So this is the language of all the words ending at A. Next we see another FA, and you have to guess what it does. Just take some time to guess that. However, I give you the hint that whenever you read letter A, your state is changed. You move to the accepting state or to the starting state. The letter B doesn't make any difference. So if you are on the starting state and you read letter B, you stay here, and on the accepting state, if you read letter B, you stay here. So letter B is not making any difference. It is the letter A only which takes to you from the starting to the accepting and back to the starting state. So what language does it accept? You can let's see it like here you can see that if you read letter A, for one A you go to the accepting state, but if you read another letter A you move back to the starting state, and then for the third A again you move to the accepting state, then for the fourth A you move back to the starting state, and for the fifth A you move back to the accepting state. So from here you can conclude that this automata or this machine accepts those words which have odd number of A's. And here we have another automata just for the practice. Here it says it will accept any word that contains at least a single double A, and for a single double A, for double A letter, if you read letter A, then again A, you reach up there, and then once you are on the accepting state, you stay there for any letter, and after first A, if you read B, you come back to the starting state, then you read B, so you stay here. So whenever you read two consecutive A's, A and A, that's double A, only then you move to the accepting state. So here is another automata. You can study it in two different levels. The upper half says that if you start with A and then you end at B, you goes to the accepting state. So the words, if the word starts with A, they must end at B, and if the lower half is the reciprocal of the upper half, if you start with B, you must end at A. So next we see, and so for the next in the next lecture we will discuss the even language in detail, and we will also see how we can define automata for even language.